Hi everyone, we are back and we are going to look at our contingency tables in chi-square. So before we start this problem, I want to make sure that we have all of our relevant notebooks and resources available. So let's look at, we want to have our lecture 8 notebook. We want to have our lecture 8R, and let's go ahead and open up these resources. We have our R book as well. So let's start to read these in so that we're ready to go. Let's read in this. And now let's go ahead and let's get started. So the first question is asking, looking at these contingency tables, write out the expected values and totals in a table. So one way we can do this is with our Mathematica notebook. So let's go ahead and we are going to set up our data. So our data is going to read as follows. So we're going to do it, you can essentially see here by row. So 3, 1, 70, 8, 5. And I'm going to copy this and I'm just going to paste it. Second row, oops. So I'm going to actually copy it like this. 2 rows. 3 rows, 4 rows, 5 rows. All right. So 3, then we're 0, 0, 1, 0, 0. Then we're going to be, we want to get rid of these double commas. Then we're going to be here, which is going to be 1, 0, 30, 2, 1. Then we're going to be 0, 0, 30, 2, 3. And then finally, we're going to be 0, 0, 3, 0, 1. So that's our data. We can double check that it's in the correct format, which is great. So this is our observed data. So now we need, what are the expected values in that table? So we can actually go through here, and this is our general, actually, that's not our most general. This is our most general function for getting our expected values in our table. So remember, the way that we do this, and we could double check, obviously, to make sure that this code is actually working, so that we can do, we need observe obsdat. Obsdat, obsdat, obstat, 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 obstat. So let's look at this, and let's do expect value matrix form. So here's our values. So remember, the way that we get these expected values is we need to find what are the totals. So we need the total for each of the rows, the total for each of the columns, and then divided by the total. So if I were looking at this cell, it would be the total of this times the total of this over the total of that. So let's go ahead and just prove our first function, and it actually works. So I'm going to go to, let's do observe dat. So I want to pull out basically all of the rows in the first column. So that would give me my column total. So I would just do observe dat total. And then I would do observe dat. And I would do bracket 1. Yep. No, that's not. Ooh, I missed a column here. Yikes. But no worries. We can just put it in right here. So we have 0, 3, 49, 1, 2. So we have another value here. Observe dat. And then we can do this. And now we got this. So now I can take this, and I can do my total of this, and then I can just do flatten of observe dat. 1. Actually, just flatten observe dat, and then I can do total. This is just going to give me all of the measurements. So I can do, for example, this times this divided by that. 1.018 let's see, where's my new? This is my new expected values. 1.01852 in the top left. We got it. That is it. So we are good to go there. Fantastic. So what are going to be my degrees of freedom? Well, it's going to be the number of rows. 1, 2, 3, 4. Actually, 1, 2, 3, 4, 5, 6. So 5 times 1, 2, 3, 4, 5. So my total degrees of freedom are going to be 5 times 4. So 20. So we should expect to see that. And actually, we can calculate... actually, we can calculate our chi-squared right now. So this would be my chi-squared value. So my chi-squared experimental... I know we're getting ahead of this. Those are the total degrees and freedom should be 20. So chi-squared experimental is equal to, what was that? Let's go back. 16.58. My chi-squared, my alpha here, what do we asked? 1%, so 0.01, 20. So let's go chi-squared, 0.01, 20, 37.566. So what are we saying here? Well, we are in the do not reject regime. So we are saying that, again, these variables are basically independent. So let's go back to our notes. We can kind of confirm this. So let's go to our lecture 8. So we can kind of see here. Through, we're looking at the values here. Do not reject regime. Relationship the DX are not statistically significant. There's no relationship between the variables. So again, if we're in the do not reject, that's what we're saying here. So there is no relationship. They are independent. So excuse me, they are not correlated. And that is indeed what we find. So let's double check that with our R code. So we can take, and we can actually read in this same data set. And let's go ahead and do that. So let's read in our values here. So let's call our matrix. And again, we're just going to read in. So let's just type in our values. Whoops. So it's going to be 0, 3, 49, 1, 2, 3, 1, 70, 8, 5, 0, 0, 1, 0, 0, 1, 0, 30, 2, 1, comma 0, comma 0, comma 30, comma 2, comma 3, comma 0, comma 0, comma 3, comma 0, comma 1. And we're going to find that for our columns, we're going to name these quite simply. So, oops. Let's get this back in here. Bike, bus, drive, O, and then walk. And then for our rows, just going to name it BLU, blue, BR, GR, green, hazel, other. Oops. All right, and then we're going to organize it by number of columns. 1, 2, 3, 4, 5. Good. By row, true. Good. So let's take a peek. We're going to run this, run this, run this. Run it. Let's look at our data. Does it look correct? Yep, that looks pretty good. Chi-squared. Same value here, same value here. P-value, do not reject. We got it. Excellent. Finally, we're looking at 52 cards. We see we're looking at randomly pulling players from a deck. So drew 520 cards. They played a lot of games. They replaced the card in the deck each after. So these were the observed So we need to figure out what are some observed and expected values. So I'm going to actually use my... Actually, let's go back and let's use the code from... I'm going to use my lecture 6 code way back in week 7, maybe? Or then I saw, maybe it was just on our pages in week 9. Oh yeah, lecture 6, here we go. Use that right here. And let's go ahead and let's put that over here. So where are my observed values? So let's go to this problem. Let's go to my Mathematica notebook. So my observed are 16, 270, 14, 245, 131, 53, 13. My expected are going to be, so a 7 of clubs will be 1 out of 52, the probability. So I need to multiply times all of this times the total number of the, basically, number of cards pulled. So that's the probability for this. Black cards will be 1/2. Red 9s will be what? So there's 2 red 9s, so 2 out of 52. Red cards is another half. Jacks, kings, and queens. So there are 2 jacks, or actually, excuse me, 4, 4, 4. So that's going to be 12 divided by 52. Black jacks, kings, and queens. So that's going to be 6 out of 52. And then 2 of diamonds. That's only going to be 1 out of 52. So those are my expected values. Observed minus expected. So my chi-squared is 8.875. 75. And then I have 1, 2, 3, 4, 5, 6, 7 outcomes. So my chi-squared, 5% significance, 0.05. 1, 2, 3, 4, 5, 6, 7. So what's my chi-squared of this? 0.05 and 6, 12.592. So that is going to be a big old do not reject. That's it. Join us next time for our last problem in ANOVA, and we'll be on our way. Thanks. See you then. Bye.